All right, let's solve some equations. So we start with a little bit of a warning here, just like a heads up, that when you solve equations that have radicals in them, it is not uncommon to get extraneous roots. The last time we encountered this term, extraneous roots, was when we were solving equations with fractions. And in that case, it was like you'd get a solution that led to division by 0 in the original equation. But extraneous roots in general just means that it's a solution that you might arrive at like without making, any algebraic mistakes, right? Like all your moves are correct, you arrive at some solutions, but they just don't check out in the original equation. So that's always a possibility with these equations with radicals. So check answers you get in the original equation. So our basic technique is to just isolate one radical. If there's only one radical that appears in the equation, that's easy enough, right? And then we square or raise to whatever power that, if it was a cube root, I'd cube both sides, or if it's a fifth root, I'd raise each side to the fifth power. So you can get rid of that single radical and simplify whatever you get. If there are still radicals left over, you just repeat the process. Isolate another radical, square both sides or whatever. And that, you might need to repeat that depending on how many radicals are in the original equation. You'll have to repeat that some finite number of times. But you will eventually be looking at an equation with no radicals at all. And it'll be a type of equation we know how to solve, like a linear equation or maybe a quadratic equation. So, for example, if we want to solve this equation, 2 times the square root of 3x minus 1 is equal to 3x. Now, you could look at this and you could go one of two ways. You could say, well, if I really want to get that radical by itself, I'll divide both sides by 2. That's legit. Or you could think of this radical as already isolated because there's no addition here. It's just a factor of 2. And then you could go jump right into squaring. Either will work just fine. What do you feel like doing? Divide by 2. So this means that we have the square root of 3x minus 1 is equal to 3x over 2. Now we have that radical by itself. Let's square both sides. On the left side, we just get, we're squaring a square root, so we just get the stuff inside. On the other side, what do we get when we square 3x over 2?
9x squared over 4.
Mm-hmm. Good. So this is a quadratic equation. Let's see how we want to proceed here. I'm going to get rid of the fractions first. So I'll multiply both sides by 4. We have 12x minus 4 is equal to 9x squared. I mean, once you get rid of the radical, at that point, it becomes a different kind of problem. So now I'm just thinking, okay, my head's in like quadratic territory now. What do you think we should do to solve the quadratic equation? Anybody remember doing that last semester?
Use the formula?
We could. If we have to resort to the formula, that's okay. Here's my feeling about the formula. The formula can be a good and necessary tool when we have like really inconvenient numbers or lots of decimals. But aside from that, I think of the quadratic formula as something that makes it easy for us to not understand how to solve quadratic equations, right? So yeah, the other two techniques were either factoring or complete the square. Not every quadratic factors, but if it does, that's certainly a good method to use. So let's see, in order for factoring to work, what do we need?
Get them all on the same side.
Yeah, and I like starting out with a nice positive squared term. So if we subtract 12x and add 4 to both sides. we have 9x squared minus 12x plus 4. And then we want to see what happens here. And does this factor? I'm not sure. So I know I'm looking for stuff where the first two things multiply out to 9x squared, the last two have to multiply out to 4. And I think maybe 3x and 2 will work. What has to be the signs in the middle? They both have to be a minus, yeah. And then if we do a quick check, this is a minus 6x and a minus 6x. So this seems to work out okay, right? That gives us the minus 12x that we were looking for. How does this solving by factoring work? Like, where do we go from here?
Set each set of parentheses to 0.
Yeah, because if you multiply two things and get 0, the only way that could happen is if one of your factors was 0 in the first place. That's why the solving by factoring only works if the whole thing is set equal to 0, right? If the product of two things equal to 2, it need not be the case that one of those things one of those factors was 2 in the first place. But that is true with zeros. So that means that either 3x minus 2 is 0 or 3x minus 2 is 0. I'm going to go ahead and say, let's just solve one of these. You know, unless you really, really want to do them both. But I feel pretty confident about our results. So this means 3x is equal to 2, or x is 2/3. So we have one answer. So this one answer that we get, chances are pretty good that it'll work out, but I'm not moving on from this example until we do a check, because I know that extraneous roots can happen with equations that have radicals. So I'm checking to see, is 2 times the square root of 3 times 2/3 minus 1, is this equal to 3 times 2/3? So I'll work on the left side. 3 times 2/3. This is 2 times the square root of 2 minus 1. 2 times the square root of 1, which is 2 on the other side. 3 times 2/3 is 2. Yes, it works. More?
Oh yeah.
Oh yeah. What should we do first here?
Cube it.
Yeah, I mean the radical's already by itself, so we'll undo the cube root by cubing both sides. What equation results from this step?
X minus 8 equals 8.
Yeah. Now we have a nice linear equation to solve. And a couple seconds later, we come out with x is equal to 16. What do we do next?
Check.
Check, yeah. We get the cube root of 8. That is, in fact, equal to 2. Which means x equals 16 is a solution. More?
Uh-huh.
May as well. How do we begin this one?
Isolate the radical.
Yeah. And here really we have to do that. Like this is in the first example, we divided both sides by 2, but we could have started out just by squaring it, and the big difference is that's a factor of 2, so that's fine. Here, the big difference is that this is plus 3. It's not just, the radical's not being multiplied by a number, we're adding. There's a whole other term there. So we really have no choice but to start out by subtracting 3. And now that we've isolated, we can go ahead and square. The left side, of course, you square root, we just get what's inside. On the right side, you got to be careful, right? Let's do our algebra out. This is x minus 3 times x minus 3, which gives you what?
X squared.
Minus 7x plus 10.
Wait,
6x
minus 6x
plus 9.
plus 9, yeah. Oh, you were already, yeah. We have another quadratic. So it sounds like Deep was getting ready to solve this by factoring, maybe? Is that why you were collecting all the terms on one side? So if we try to solve this one by factoring, we have x squared minus 7x plus 10. This one's a little bit easier to factor because it's a monic quadratic. How does it factor? X minus 5 times x minus 2. So we get 2 solutions here. So we get x equals 5, x equals 2. So the next thing we need to do is check both of these in the equation. In the original equation. Here's the thing, is like these two equations, these two solutions, x equals 5 and x equals 2, they are absolutely solutions to this equation that we got after we got rid of the radicals, right? So we need to check to make sure and see if they are both solutions to this equation with the radicals. So let's check one at a time. X equals 5. So square root of 5 minus 1 plus 3, is this equal to 5? So square root of 4 plus 3, which is 2, plus 3, that is, in fact, equal to 5. So x equals 5 is a solution. I'm going to put that one in a box. So now the other one to check is x equals 2. So I want to see if the square root of 2 minus 1 plus 3, see if that's equal to 2. The square root of 2 minus 1 is just the square root of 1, which is 1, plus 3, and which is 4. And you know what's true about 4?
It's not 5.
It's not, well, it's not 2. Right? On this one, the equation is equals x, so our other side is 2. So 4 is not equal to 2, which means x equals 2 is not a solution. So we get just one solution to this, which is x equals 5. How's that so far? All right. Let's have some fun with this one. What do we do first?
That's a great question.
Yeah.
Could you square both sides, like putting both
Sure.
radicals in a parentheses and distributing?
Like square both sides out, so we get like the square root of x, like do this, you mean?
Yeah.
Okay. Yeah, so let's see what we get. So that would be, I'm going to make the little box here. So we got x, root x plus 1, root x minus 4. And then we're multiplying that by itself. So root x plus 1 times root x plus 1 is x plus 1. Then we get root x plus 1 x minus 4, root x plus 1 x minus 4, and then x minus 4. So we still end up with these radicals. So let's try a different approach. What does our procedure say?
Isolate one radical.
Isolate one radical? Okay. So let's isolate one radical first. It doesn't matter which, so pick one. The first one? So that means I'm going to subtract root x minus 4 from both sides. So then we have root x plus 1 equals 5 minus root x minus 4. Now, yeah, let's try squaring both sides here. So the left side, we're just squaring a square root, so that'll be nice. The right side, we'll still have to do some foiling, but let's just see where that leads us. Oh, whoops. That's a minus.
It's also minus 4.
Oh, gosh. Thank you. So, let's see, 25, and then minus 5 times this radical, minus 5 times the radical, and then plus x minus 4, right? So we got, let's see, 25 minus 4 is 21. And then we have this x term. So we have x plus 21. And then what about along this other diagonal? What's going on here? Yeah, so minus 10 root x minus 4. So, you know, we still have radicals, but we have just one radical. You know, we started out with an equation that had two radicals. We now have this equation that has just one radical, which means we can isolate that radical and square again. This is that repeat if necessary part of the procedure. So, I don't know, maybe let's subtract x and subtract 21. So we got minus 20 is minus 10 times the radical x minus 4. And maybe let's go ahead and divide by negative 10. Because then we have 2 is equal to this radical. Pretty nice, huh? Now we can square both sides again. So we get 4 is equal to x minus 4, or I think positive 8,
Oh.
right? Yeah. Now what?
Check it.
Check it. Yep. So our equation, we want to see is the square root of 8 plus 1 plus the square root of 8 minus 4, is that equal to 5? So we have root 9 plus root 4, which is 3 plus 2. Yes, in fact, 3 plus 2 is equal to 5. Nice.